This Talend data map tutorial covers COBOL.
Okay, now we're going to show some COBOL support. So generally you start with a copybook. So here's a copybook of something found on the internet. And you can see a O1 level, a shipment record. And this copybook here has uses redefines, which is very typical in COBOL. And it's also very typical to have a record type or a couple characters at the beginning of the file that describe what kind of record it is, and for the file to be a positional file. So in this case, we have several different types of records. A record type here, each record has a record type field at the beginning, and it has an 88 indicating the value. So this 88 level in COBOL indicates a constant value that's possible for that type. So we go and we look at all the different types of records. So that's what's defined in the copybook. So now let's go through and import that copybook. So we select import, and we want to import a COBOL copybook, and we want to pick a resource in the workspace. And we'll continue on. So here there's an option to say if the lines are separated by new line characters. Sometimes you get COBOL where it's not really positional, but it's essentially delimited by new line characters in each line. That's not the case here. The character encoding, if it's COBOL, sometimes you get it as ASCII, but in general, if it's EBCDIC, then you want to select an EBCDIC encoding, a typical one that is IBM 37. And also there's some help here if the encoding you want is not found. If you click on this link here, it will give you some text about why it might not be there. You might have to look at your JDK, or and if you're looking for EBCDIC, it will give you some hints as far as how to find that when the help comes up here. This is the first time starting help, so sometimes it takes a second. Here we go. So it'll basically talk about the issues associated with finding the right character encoding. Then the next part is if the line number start columns. So you can either specify them explicitly, or you can use this freeform option, and the importer will try to figure it out. Then at this point, it's looked at the copybook and it's determined the top level records. And so you can select any of the records that you want. In this case, there's only one, but in a lot of copybooks, there are multiple O1 levels. And then finally, in some cases, you have essentially a loop or a file that consists of many of these records together. So what you want is to have the structure generated with a loop. In some cases you don't. You have a single record in a file, so you don't want the extra loop. In this case we do. And this will ask where it wants to be stored. I'll add some characters here so that it doesn't interfere with the one that's already there. And then it's done. So if we look at what it did, it generated a structure here, and it generated a choice. It detected the redefines case, and it generated a choice for each branch of the redefine. I'm going to look at one that was previously imported and associated with the sample document. So here we're actually now looking through the sample document, and we can see the first branch of the choice is this file header, this FH record. So what it did was it looked at the record type and it looked at the 88, and it included an initiator character string here that says, okay, when it finds this character, then no, I don't want to do that. So when it finds this character, then it will process in this branch of the choice. So in each branch of the choice, the record type has an initiator character here of the right record type. And notice that the size of the record type is 0 because we're actually consuming these initiator characters here and not showing them through in the field, because we actually don't really care about the record type when we're further processing. We can detect that in other ways. Uh, so the option to control that, though, you can do two ways with that. Um, Here the initiator is specified, and you can also say if you want to include the initiator in the value of the field. So we could also say to include the initiator in the value of the field here. We'll turn that on, and then we'll make the size of the field to be 2 bytes. So then we'll save that. So if we're looking at the record, we'll notice as you look through, as you click on things, it will highlight the elements. So it will tell you that it's happy and it's happening. So if we do a show document here, we say show sample, we can see that the record type here is actually populated with this DH value because we've elected to include the initiator in the output value. Whereas if we do a show sample here when the FH record, we can see that the record type is empty because it uses the record type to detect where it wants to start, but it's consuming that and it's not outputting that to a field. So again, here's the contrast here where it's consuming it, and here it's not consuming it, and here you see initiator value included in element value. So that's useful in various situations. So this was automatically generated because we detected this idiom of the redefines and the characters that start the constant character, and the fact that there was a single constant character for each branch in the redefine. So now I'm going to show another COBOL import. This is something that we did for American Express, and let me find this. Here's what the COBOL copybook looks like. So there, in this case, there are several O1 fields here, and here's the record type, and they've defined all these constants, and then each branch here has it sort of duplicates some header information in each branch, the record type and record number, and then their records for various purposes. So this is sort of a more interesting case. So now let's look at, I'm not going to actually do the import, but now let's look at the structure and see what we have. So what we did for this is essentially created an outer structure by hand because we wanted to, the importer produced, if we look at the structures the importer produced, it produced a structure for each of the O1 levels. So here, for example, the FHR structure is that O1 level. They all start with the record type. So what we want to do now is we want to process this file, and this file is a collection of these structures in a certain order. So what we did was we created a root element. We just created a structure by hand, creating a root element, and then created a structure. It created an element for each level, and this is a sequence. This root element, you see, group type sequence, and we have the FHR record, which inherits from this FHR record data structure. We have the TFH record, which inherits from that structure, and so in this, the FHR appears first, the TFH appears next, and so forth. Now the TAA structure in this case is a little bit more interesting. So here, we actually modified the way this TAA structure works. You see a whole bunch of TAA structures, and they have to do with, you know, air travel, auto rental, and so forth. So what we did was, if we look at one of these TAA structures, you see there's some actually they were removed here, but there were these fields in the front of each of these TAA structures. So what I did was I chopped them out and put these fields at the beginning of the TAA structure, since they always appear, and then added a choice element here. So this was done manually. So the choice says, okay, take one of these branches. And what had the logic for this um, was that if you take the auto rental branch, if the add type code is a 3 and the format code is a 5. So there's different rules in that describe the business rules that describe the data and tell you which branch you need to take. So they gave us these rules, and this is how we encode those rules. So you can use the isPresent expression, the isPresent tab. You can use that directly in the flat file. You can use that directly in the flat file handling or any kind of handling to tell you which branch of a choice to take. So if you have a choice on input, then you specify an isPresent expression to tell you which branch of the choice to take. And in that, you can actually reference any of the data that occurs before that time. So in fact, this is evaluated before the map is even processed. This is evaluated in the flat file handling before the data is actually presented to the main engine to execute the map. So obviously you can only specify things that have occurred before before it in the file. So here, for example, is the error record, and if we look at the isPresent, we have another condition here. So this was an example of using the importer and also combining the record types that were given and adding the logic that is required to interpret the COBOL document. Now this logic in these redefines cases is normally not machine encodable, so you have to add that by hand, and we have a really nice way of adding it by hand using this isPresent expression. So now I'm going to look at one more structure. This was created by Terry Hoff in pre-sales, which is the one I'm showing you I created as sort of a first cut at this. And Terry went much further with this. This is exactly the same data, and it's based on exactly the same file and so forth. And it's a more general way of processing this. So I'm showing it to you now with a map. So he uses the same technique. Here he has a loop. So essentially, this allows the data to be handled in any order that occurs and respects the record type. So here we have a loop, and here's a branch which, if we look at this element, it should inherit. It actually doesn't in this case, but it should inherit from each of these structures here. And then he's defined the if-present expression to be sensitive to the record type. So if the record type is FHR, then it will use this. If the record type is FHR, then it will go down this FHR branch, and so forth with TFH and all that. Now we look down at the TAA header, which is that thing which required more logic. Here's the header information, and here are the records. So if we look at the choice in each case here, we see the same kind of logic, where if the add type code is 3 and the error format code and the format code is 1, then go down to the error record and so forth. So and then this actually goes to an output file. And in this case, what we're doing is we're taking these are extremely large files, gigabyte files, and we're reading the COBOL, and we're outputting a separate file for each type of record. So what we did was created a structure all based on the same data. So there's no modification to the data that goes through. So here we've created a structure. We've created a structure which inherits from the structures that were imported from this FHR record here. And we created if we look at these structures, we created a output structure for each type of record. So the output structure has a root, it has a loop, and the loop inherits from the record data. So we're not copying the record data at all. We're just using inheritance to refer to the record data, which is the same as the input. So in each of these output structures, we have defined a loop. So it says that this FHR record will, there could be multiple FHR records emitted. Now, to have it go to a separate file, we use, in the IO database tab, we use a write URL function. And if we look at the properties of the write URL function, we see that it wants to go to XML, and we see the name of the file. So if we run this map, we see here's the FHR records. There's only one of them. Here's TFH in the loop, which there's only one, TAB, and on and on. And when you test run a map that has output to file or output to database, when you just do a normal test run, it will show everything that goes to the output in one display. So it doesn't respect the write URL or the write to database and all that when you do a test run. But if you want to actually run it, in this case, to go to the files, then you would say test run to external output, or in the case of database, test run to database. And it will actually execute the IO functions and write them to the files. Now these are not set up for this machine, so I'm not going to do that. But that's the way, in the case of multiple outputs, that you specify multiple outputs and that you can actually test them in the designer. So here I've, just to summarize, I've shown how you import COBOL copybooks. I've shown how you select if you want to have the structures built with a loop or not in the import process. The imports, once it's imported, you're using the logic of the flat file processor, which is not specific to COBOL at all. It doesn't understand anything of COBOL. It just understands the rules associated with processing flat files. This is the same for CSV and also the same for any arbitrary flat files. And then I've shown how you can encode the redefine rules or any other sort of rules you like by using the isPresent function and dictating your logic of a choice statement, of a choice group type. And also how you could, I previously showed how you can do that with using the initiators and terminator characters. So this concludes the COBOL part of the tutorial.